Have you ever wanted to build a GUI application from scratch in C++? Well, if so, maybe this video is just right for you. In this video, I want to show you the capabilities of a GUI library set called CopperSpice. I want to show you what CopperSpice can do for you and how you can build your first project on either an Ubuntu system or on a Windows system with WSL already installed and a X server set up. So what you see here on my screen, that is basically the demo application of the CopperSpice library set. We will build this together, but for now, let's just go through this application and see what the libraries already include for you. Here are a whole bunch of examples. I won't go through all of them. If you have questions, just leave a comment. First of all, you can do things like font selection, and a cool thing to see here is that CopperSpice uses already existing standard dialogues that your operating system provides. Another thing that you can use are things like tree views. These are also already implemented in the library, so you don't have to build them yourselves. You can use other standard dialogues, like, for example, get open file name. This opens a regular file explorer. You can just type OK. It adds the path. You can display message boxes and get the user's feedback from those message boxes. Or you can use things like this calendar widget, which is pretty neat if you need that in your application. And you can also render graphics inside of your own CopperSpice application. So enough of the demo. Well, what is CopperSpice? CopperSpice is a set of libraries. You can get more information about the CopperSpice libraries on www.copperspice.com. It's a project that has been forked from an earlier version of Qt, if you have ever heard of Qt or the Qt framework. It's licensed under LGPL v2, which means it's open source and you can use it for your own applications, whether you want to build open source applications or even commercial applications, and it compiles with GCC, Clang, or MSVC. We're going to use GCC in this example. All right, so before we start, let's find out whether we have everything installed that we need in order to build our CopperSpice application. There are three things that you need to check, which is one is GCC. Okay, I've got GCC installed, version 11. Okay, and also I'm running Ubuntu 22.04. You want to make sure that you've got CMake installed. You can see CMake is installed with version 3.22. And we want to make sure that Make is installed. Make is also installed. So if one of these are not already installed, use your package manager to install them. The versions that are in the Ubuntu package manager are recent enough to build. Okay, in order to build C++ programs, we will often need precompiled libraries that our program will link against. Especially when it comes to GUI libraries, there are a whole bunch of libraries that we need, that our compiler needs to link against. And if you want to find out whether you which one you need, well, you can go to copperspice.com/docs, and then on CopperSpice overview, go to building CopperSpice, required packages for Unix, and scroll to, well, the distribution that you are on, and you will see a complete list of libraries that you need. Now I have to get back to Ubuntu 22. Here's Ubuntu 22. You see here's also here are also the commands to install what you need. If you're on Ubuntu 22, I also prepared a gist that you can just clone and use. Oh, I should mention you need Git to run this tutorial. So I will just clone this gist, cloning it into this weird directory, 5, that's just the hash, and you see there's the get csdependencies.sh. I'm using chmod to make this file executable, and then I want to run it. Okay, of course, it says I can't open log file because I didn't use the super user permission. Since we want to install something, we should do that as super user. Just to be clear here, don't run super user commands on just anything that you download from the internet. Read the command first and be sure that you know what is going to happen. Just cloning scripts from the internet and running sudo might be a bad idea. Well, in my case, since I've already built an application with CopperSpice, all of these libraries are already installed and on the newest version. So I don't need that right now, just wanted to show you that. So I'm deleting this directory, but I'm going to make a new one, which is called CS demo. Okay, so moving into CS demo, and what we need to build Kitchensink are two things. First of all, we need the CopperSpice libraries, the CopperSpice binaries themselves. Yeah, so the pre-built library. It doesn't come in the package manager, so we have to download this. We have to download this on its own, and then we will need the Kitchensink sources. So let's download the CopperSpice binaries. First place, CopperSpice binaries, downloading source, installing CopperSpice binaries. Here it is, installing on Unix. Want to get the Unix binaries. This is the binary download page, and if you don't know which distribution you're on, you can also run lsb release --a, and you will find out what distribution you're running on. I'm running on Ubuntu 22, so I'm going to right click, copy the address, then use curl-O and download this archive. This is going to take a couple of seconds. Now we see here is the archive. I'm going to make a new folder. going to call it CopperSpice lib. Okay. And now I want to extract that archive. Extract that archive with tar and use this optional parameter -C. That means extract it into this specific directory that I gave to tar. All right, so while this extracts everything, we can go and search for the Kitchensink sources. To find the Kitchensink sources, you want to go to GitHub and find them there, but I'm going to type GitHub and CopperSpice Kitchensink. And if you Google like this, this should come up as the first entry. So as you've seen, Kitchensink is a demo application, and we want to use this demo application to figure out whether we can build a CopperSpice program or not. Because the thing is, if we would just start building our own program and it doesn't compile, we don't really know, is it our program that doesn't compile, or is there something wrong with our installation? So I recommend you download Kitchensink first and try to build Kitchensink. I should mention Kitchensink is, or the CopperSpice libraries are primarily maintained by Barbara Geller and Ansel Sermersheim. They also have like a Twitter account, an email account, they have a forum, they have a journal if you need additional information. All of those are really good resources. So we want to clone this. Git clone Kitchensink. All right. So we downloaded the binaries from libraries, and we downloaded the source code for Kitchensink. Now we want to build Kitchensink. Building Kitchensink requires CMake, a compiler, and bin utils or make. So we're going to go into Kitchensink directory, and here are all the sources. First thing we're going to do is we're going to create a build folder, and then we're going to go into this build folder, and we're going to call CMake, CMake to set up our build system. Right? So CMake ... because the CMake lists.txt is in the file, in the folder above our current folder. Now CMake's running, trying to configure my workspace, my build directory, and we get an error message. And the error message tells us CMake error at CMake list, find package. It can't find the CopperSpice libraries. It can't find the CopperSpice libraries because we didn't tell neither our shell nor CMake where to find the CopperSpice libraries. So what I'm going to do is I'm going to figure out where they are. Well, we installed them here, right? And it wants to find the CopperSpice config CMake file. And let's look where it is. It's in lib CMake CopperSpice. So it's in the archive that we just extracted. So this archive might be, or wherever you put it, might have a long path, So we're using the pwd command to figure out that path. So one way you could now run CMake. First of all, let's clear all of the stuff that was in the build directory. One way you could run CMake now is CMake. We want to set this parameter, the CMake prefix path. So we want to add another path where CMake searches for libraries. And we can take this and put it in here, right? We can add the path like this. There's one option, and then we're going to run CMake again, and you can see configuring done, generating done, build files have been written. Something else that you can do is put the path into an environment variable. I like to do that. I'm not going to show this here, but if you know how to set and unset environment variables, make sure that you set an environment variable for this. Okay, we didn't build yet. We just ran basically the configuration. So the next thing we're going to do is call CMake --build, and since our build files in our current directory, we want to run it here. Compiling the library actually takes some time. It runs a little bit slower on my machine than it might run on your machine, but bear with me for a second. One thing why I really like Kitchensink is that not only can you try out all of the widgets and thingies that are in the application, you can also go to the actual repository, go into the sources, and, well, look how it's actually built, right? So you can go into the source files and you can look how is, for example, the color picker implemented, right? And Barbara and Ansel, the two core maintainers of CopperSpice, they really have a good coding style. That's something that you won't see in many other in so many other open source projects. Here I am in the main.cpp. You can see it's a really short it's a really short main, actually, because the only thing that is really done in main is to create this application object, which is basically an event system. If you have no idea what an event system is, you can also think of it as sort of a state machine. That is not entirely correct, but the event system consumes events and triggers actions on those events. When we go a little bit more into the details, maybe in the upcoming videos, you will see things like signals and slots. So those are the things that we use in such event systems. The second thing that is set up here is the main window object, and we can see it includes the main window.h. So we're going to look into the main window just in a second, and then it calls the method .show from the main window, which displays the main window and return app.exec, this actually starts the event system. So those 3 lines, they set up the event system and they set up the actual window and show the window. Then this this statement executes the event system. And when the event system returns, well, that is also the return code that's going to be returned to our operating system. Let's look into the main CPP, main window.cpp. You can see there a bunch of includes in main window CPP. And main window is actually the class that you will be using for building your own applications as well, right? And you can see this connect statement here. And what connect does, it connects a so-called signal to a slot. A signal is something that can be, well, this has triggered. A signal is something that happens. Well, that happens. Yes, yeah, something that happens, and a slot is typically something that consumes an event, right? For example, this add main window action close window. This is a strange syntax. It's called a method pointer. Don't get too much into the details. You don't have to understand that right now. You're allowed to use it without understanding it properly. Right, so what else do we see here? You see that all of the UI elements are actually being created in a method of this class. Oh yeah, and the about section is set up. Also, attributes like the minimum width is set in this class. Well, this is just for the about action, right? For the about action model. All right, so after a couple of minutes of compiling, you can see 100% built target Kitchensink. What we can see here is now a folder called bin, but if we try to run that, we will get an error message because this is not yet properly linkable against some of the dynamic libraries from the operating system. So we have to do a third and last step, which is called CMake -install. I want to don't get confused by the term install. It doesn't install anything into the operating system. It just builds a real package. And I want to have this package in this folder, so I used dot, but also I want to give it this prefix called deploy. So there's going to be a new directory called deploy. See, it's running. Run ls again. Now there is a folder called deploy. We log into this, and this is everything we need for the actual application. This also looks more like a real application, right? Like a real application folder. I run .kitchensink, and here's our GUI application, freshly built. And with that, you can now go ahead and change the source code and build your own program.